So now we're going to do a normal force example, but in this example, we're not just going to be standing still. We're going to have an applied force on us. So for this example 2, a 73 kilogram Mr. Scaver is carrying a 20 kilogram bag full of physics experiments. Determine the normal force acting on Mr. Scaver. What is his apparent weight? So at this point, let's figure out the normal force. So find Fn. Now let's kind of draw a rough sketch of what's happening here. So there I am, and I'm happy because I got a backpack full of physics experiments. Now, the mass of myself, let's call myself mass 1, I'm 73 kilograms, stated in the question. Now mass 2 is my backpack, and that thing is 20 kilograms. So what's occurring here? Well, technically that backpack is sitting on me. It's applying a force down on top of my shoulders. So what's occurring to the ground here? The ground feels two forces. It feels a force of gravity due to myself, so 1, which will be the mass of 1 times the gravity. And this is Fg on Mr. S. But then on top of that, I have an applied force from this backpack that's pushing down on me. So there's another force of gravity pushing down, and that's the backpack, F2. So this will be the mass of 2 times the gravity. Now recognize I am not moving here. I'm just standing still. So since I'm not moving up or down, that means something has to be counteracting these two forces, which is, in fact, the normal force that the ground is applying on me. So from here, we can start creating a net force equation. Now recognize my net force equals 0 newtons. Why does it equal 0 newtons? Because I am not moving. As soon as you start accelerating somewhere, then you have a net force. I shouldn't even say I'm not moving, because technically moving, it should say I am not accelerating, because accelerating is the thing that makes net force occur. So now in this part, let's create the sum of forces. So my normal force is opposing my two forces of gravity. So I'm going to add the force of gravity 2. No, I'm not going to add, I'm going to subtract because it's going in the opposite direction. Sorry about that. So again, net force is directed upwards, the force of gravity is directed down. Along with that, my force of gravity on myself is going down. So now I have an equation that I can start determining my normal force. So again, net force is 0 newtons. We're solving for the normal force minus, and we can plug some values in here. The force of gravity 2 is the mass of 2 times the gravity minus the force of gravity 1, which is the mass of 1 times gravity. So 0 newtons will equal the normal force minus mass of 2, which was my backpack, and my backpack was 20 kilograms, times 9.81 meters per second squared, minus the mass of 1, which was 73 kilograms, times 9.81 since we're on Earth. And now I can plug these values into my calculator. So 20 times 9.81. So there we get 0 newtons equaling the net force minus 196.2 newtons. And we're going to subtract 73 times 9.81. And that gives me 716.13 newtons. And now at this point, we can combine and solve. So let's take these two numbers, and I'm going to include that negative. Negative 196.2 subtract 716.13. So 0 newtons, whoops. 0 newtons equals the normal force minus 912.33 newtons. And now I can add 912.33 newtons to both sides. And therefore, I have learned that my normal force is 912.33 newtons, and there's my normal force. And again, a normal force is a force, therefore we should actually put a direction in there. And this would be upwards, opposing my two other forces. Now at this point, I should probably represent it also in scientific notation, so 9.2 times 10 to the 2 newtons up. There we go. Now, we figured out the normal force, so the force perpendicular to the surface I'm sitting on. Now it asks for the apparent weight. But understand, think about when you put a really heavy backpack on. It technically makes you feel heavier. It's the apparent weight you feel. And remember what we talked about going through this video. Your normal force is known as the apparent weight. So here, we calculated that I normally feel 270 newtons just standing still. But with my backpack on, now I weigh a whopping 912 newtons. So at this point, my apparent weight is my normal force. So Fn equals my apparent weight. So weight apparent, WA. So Mr. S feels like 912 newtons. So physics is kind of funny when you start learning it, because you sort of have to start using maybe vocabulary or words that kind of seem strange. I guess Mr. Skaber feels 912 newtons today because he's wearing his 20-kilogram backpack. So hopefully that helps you start to understand normal force, apparent weight, and mass. And if you have any questions, let me know. And if not, give a few examples a shot.